Have you ever had a project that you worked on for a while and then left it to gather dust? I'm definitely guilty of having such project myself. So instead of having them on the shelves here gathering dust, I decided that today I'm gonna start by this one. This is a differential thermostat, and I'll update you on the progress that I've made with this project, and also open source anything that I currently have on the project so you guys can replicate this and maybe even help me out so we can push this project to being finalized. For any project like this, having a custom PCB is essential, and for that I use the services of PCBWay, which is the sponsor of today's video. PCBWay allows you to quickly make prototypes of your project, where not only you can get professional PCBs made, but you can also have them assemble your project through their PCB assembly service, and they can even 3D print or CNC machine parts of your project. Once a project evolves, PCBWay can also support you with advanced PCBs, flexible PCBs, HDI, aluminum PCBs, and a lot more manufacturing options like laser cutting, metal fabrication, and even injection molding. At the moment, they offer 10% off on the 3D printing and CNC machining services, as well as a fixed price for their assembly service, so be sure to check the link in the video description. Let's jump to the bench and I can show you what the project is, how it works, and how it operates. And here is the project here on the bench. Let me first try to clean up the dust that gathered on the project, and then I can guide you through the functions of it as it currently stands and what it currently lacks and what it has. Okay, so the project in hand is a differential thermostat, the one that is being used to control a pump that will then heat up a water boiler with a solar collector that's usually mounted on the roof. And this controller is then in charge of monitoring the temperatures, both the temperature of the solar panel and also the temperature of the boiler. The controller is made out of an Arduino Nano, a 16x2 LCD, a relay to turn on and off the pump, and we have few resistors and an LED for a status indicator, one switch that directly overrides the controller and controls the pump, two switches for controlling the menu functions, and two NTC probes that I currently have in its original package but can be replaced with the ones that are enclosed in metal, and that's the purpose of this screw terminal. So the way that it works, one of the probes reads the temperature of the solar panel, the other one reads the temperature of the boiler. Whenever there is a sufficient difference between the temperatures, the relay is being turned on, and that turns on the pump that will circulate the water until the temperature is equalized in the panel and in the boiler. And when that happens, the pump is turned off and the solar panel is left to recharge and increase in temperature. And once that difference is achieved, the whole cycle repeats. My original plan was that this controller will have additional features like negative temperature protection, freezing, holiday modes, and stuff like that. So I've done basic preparation for that, but unfortunately not all of that is implemented, as I said before, because I kind of left this project unfinished. So let me power this on and I'll show you how it works. And here is the controller in its off state. You can see that when the pump is off, I'm actually keeping the relay on. And that is for a particular reason, because I want to use the normally closed contact on the relay. And that is for a sole purpose that if something goes wrong, if the relay goes wrong or the controller is off, I want the pump to be constantly powered on so I can prevent any damage to the panel, any overheating. And if the controller fails, then the pump will hopefully be on all the time, and that would allow the water to circulate and prevent any mishaps with the boiler. So you can see on the left here we have the temperature of the boiler, which is measured by this left NTC, and then we have the temperature of the solar, which is measured with this right NTC probe. And we have the pump indication, which currently shows that the pump is off. So if I heat the NTC that measures the temperature on the solar, after a certain threshold time, we can see that now the pump is on and the relay is no longer on, meaning that the normal closed contact is now allowing the pump to operate, and this will continue until the temperatures of the probes equalize. That means that we've used all the excess heat energy that we had in the solar collector, and it's now being transferred to the boiler. We have an LED here that is showing an indication, visual indication that the pump is on, additional to the indication that we have on the screen. And if I now heat up a bit the NTC for the boiler, we can see that now it goes into an off state and it will stay there until the temperature goes up again. An interesting feature that I've added to the setup is a manual override for the pump. And for that, I have a switch here that whenever I connect, the pump is instantly turned on, and that's indicated by the LED, and we can see that the light on the relay is off. And we now have an indication that the pump is on, but it also shows that it's in an override mode. So it's not the controller that it's turning on the pump, but we've manually turned on the pump using the switch here. And that is done for a reason that whenever you want to service your solar system and possibly replace the antifreeze that's filled in, you want to have the pump circulating on so you can remove all the air from the system. And this allows you to easily do that without any rewiring or without any jumping of the relay. So you can just override that, and that will turn off and turn on the pump as you wish. That's the basic operation. Now to interface the menu that we have here, I'm using two switches that are controlled through an analog pin here. I do have a full video, if you are interested, that you can find up there on how and why you want to do that. But if we press and hold one of the buttons for 5 seconds, we go into a setup menu. And with that setup menu, we can then use the other button to either increase the value of whatever setting we are trying to control, or we can move between the different settings that the controller has. So as I said, the basic operation is implemented, but not all of the controls here are implemented. So I'll just go quickly through them and explain what each of them does and how we can control it. So the delta temperature is the difference in temperature that we should see between both of the NTC probe that we want to control. And you can see, because I wasn't pressing for some time, then the controller went back into standard operation mode. So let's turn it on again into the settings menu. And that was delta T. Delta hysteresis is the difference in the temperature that we should have beyond that set temperature. Then we have the maximum temperature of the boiler that we want to achieve, the maximum temperature of the solar panel that we should allow, the temperature at which we should cool off the boiler when in holiday mode, the temperature at which we should turn on the anti-frost protection, the minimum temperature of the solar panel that we should operate, and then I have controls for the contrast of the LCD, and I think that this is a lot better on the camera now. And also I have settings for the backlight, and that's all controlled through the Arduino Nano. I have a separate video that I highlight how it's done. Basically, that's the current state of the project. As you can see, a lot of it operates already. I just never had the time to finish it. And I'm publishing this whole thing as an open source. So I'll have the schematic. So actually, let's jump to the schematic, and I show you in a schematic how this project looks. And here is the basic schematic of the controller. We have the Arduino Nano in the middle here. We have the LCD on the right, and we have the NTC probes and the switches that control the settings here on the left. On the bottom, we have the relay module with its LED and the switch. So let's go over first through each of the sections. The LCD is relatively straightforward, so you can find examples on how you can connect that LCD through Arduino. If you want to conserve pins, you may want to check out my other video that explains how you can connect this LCD using I2C with the Arduino Nano with a certain adapter that you can have. That's also an option, and you will have then instead of using 8 lines, then you will just use only 2, and that way you can have multiple options here on the Arduino Nano if needed. On the left here, we have the 10K NTC probes, which are in series with a 10K resistor, and they're being powered from the 3.3 volt output of the Arduino Nano, which is also connected to the AREF pin, so we can have a voltage reference of 3.3 for the measurements that we do on the NTC probe. And then from the middle of those, of the NTC and the 10K resistor, we are connecting that to an analog input. So both of the probes are using a separate analog input, and another analog input is then used for the switches, which are basically following the same scheme as the NTC probes, where we have them connected with a voltage divider between 5 volts and ground, and whenever we are pressing on a certain switch, the voltage here on the probe will be different. And here on the bottom, we have one signal line that is also connected to pin D7 here on the Arduino, from where we can either use that signal to turn on and off the relay, or we can use the switch here to turn that pin high, and that way we can know that we do have a voltage that we applied using the switch, and we did a manual override on the system. And here we have the LED and its resistor, and on the output of the relay module we're gonna have the pump being connected, and this one goes to screw terminal. So that's basically it in terms of the schematic of the project. I'll have this both as an image and as an Altium project shared below this video, so check the repositories. Now let's jump into code, and I'll quickly guide you through the code of the controller. And here is the code for the controller. As I said, this is not finished, so it's a work in progress, so it's not production ready yet. And I hope that you guys will jump in and maybe help me out so we can finish this project as an open source one and improve it so people can create their own controllers. Let me go through the code here. At the beginning, we use 2 libraries. The first one that we use is the EEPROM library that we use to store all those settings that we saw in the controller, and we use the liquid crystal library obviously for showing data on the LCD screen. At the beginning, we initialize that screen with the correct pins as connected, and we also define the purpose of some of the pins and the values that we're gonna use within the code. Then we have the settings for the NTC probes. And for example, we have what's their nominal resistance, and this is 10,000 ohms or 10K, and the value of the other resistors that we use, which is also 10K. Then we have the EEPROM settings, and in the setup function we initiate the settings, we initiate the pins and then we initiate the LCD. Let's go through each of those. So let's jump to the LCD settings, and here we can see that if we have the settings initialized on the EEPROM of the Arduino Nano, then we should read whatever values we have stored there. Else we should write those values. So that means that, for example, this is a new Arduino Nano that is being set up for the first time, and we initialize this settings array with all of the defaults that we use. So for example, we have the delta T of 4 degrees, the hysteresis temperature of 4 degrees, the boiler maximum temperature of 90 degrees, the solar maximum temperature of 100 degrees, and so on. Once that executes on the first time, then every other time when we start the controller, the settings will be just read from the from that EEPROM and will be stored forever, even if we power down the Arduino. Next up, we have the setup pins function, where we specify the pin mode of each of the pins that we use. So for example, we specify the relay pin as an output, and we make sure that it's on whenever we start the controller. That means that we are turning off the pump, as I said before. Then an important thing to note here is to specify that we are using an external analog reference voltage by having the 3.3 volts connected to the AREF pin on the Arduino, and then we have the LCD contrast and backlight pins. With the init LCD functions, we are basically making sure that we have the delta character to use. We specify the size of the LCD that we use, and we also print some init text that we can just show what this contraption does. And in this case, it's a thermal control version 1.0. And now let's go to the loop function. Here I'm still using some serial output on the microcontroller because I'm still kind of debugging the whole setup. So in a nutshell, we read the value of any of the buttons. If, for example, we have a button press, then we need to do some actions based on that. So for example, if we have a difference in the pressing time that's bigger than 5,000 milliseconds, that means that we should now enter the setup. Or if we, for example, have the mode button pressed for more than 200 milliseconds, then we should update the mode. This, as I said, it's currently not implemented, so only the basic function of that button is implemented. And then once we've dealt with the buttons, what we do next is to measure both of the temperatures and then update those temperature on the serial monitor, and also update those temperatures on the LCD. Now next, if we do have a difference in the temperature as we have set it up. So for example, if the temperature of the solar minus the temperature of the boiler is bigger than the delta T that we have set, and the temperature for the hysteresis, currently we have this as 4 plus 4. So if the difference in temperature is bigger than 8 degrees, then we turn on the relay pin and we indicate that the pump is on. Otherwise, if the temperatures are equal, then we turn off the relay. At the end, we just update the LCD with the status of whatever we've set for the relay, and we can see if our indicator is false, and if we do see that the relay pin is high, that means that we've manually override and turned on the pump. So that's why we can now display that this is manually override. Otherwise, we can display the status of the pump based on the variable that we have here. And basically that's about it. So I'll have this code available on the GitHub repository. Make sure to check the links in the video description. And with that said, I hope that you like this project. I know it's not a finished one, and I usually don't publish projects that are unfinished, but this is a difference because I have this project sitting here for almost 2 years now, and I'm not sure if I'm gonna continue work and when I'm gonna continue work on that. But the idea is that we can maybe work on the project together and finalize it as a product that you guys can then implement and use on your own and not pay too much money for projects like this. Again, if you like this video, then be sure to subscribe. Make sure to hit the notification bell so you get notified when I publish new videos. And I'll see you all in the next one. Cheers!